Hey everybody, it's Mrs. Bianchi. We're looking at number 3. Brian is setting chairs in rows for graduation ceremony. He has 50 black chairs and 60 white chairs. Each row will have the same number of chairs and each row will have the same color chair. What is the greatest number of chairs that he can fit in each row? How many rows of each color chair will there be? All right, lots going on here. So let's look at the word evidence that might give us some hints on how we should approach this. The first thing you should always look for is, do you see the words greatest number of? And I see that right here, greatest number of. So what does that mean? That means we're probably going to have to find the GCF. So let's put a line here so remember that we need to find the GCF. Now the other words that I want you to always look for in these word problems is the idea of same number of. Same number of. And I see the same number of right here. Same number of. Now when you see that, then that often means that you're going to be multiplying the GCF with the sum of some numbers. In other words, we're going to be using distributive property. So I want you to get that ready. You set up your scaffolding this way every single time. All right, now the next thing that I'd like you to get in the habit of is looking again at where it says greatest number of and figure out, we want to think of a label on that. And usually you can come up with something per something. So there's usually going to be 2 labels associated with that, something per something. So let's go back and look. Greatest number of chairs that can fit in each row. So we're dealing with chairs per row. Chairs per row. Let's write that down. Chairs per row. Now another little hint is that usually the word that you put after the word per is also going to be the label that's going to go here, but we're going to need an adjective to describe how this row of chairs is different than this row of chairs. And where do we look for that? We go back into the word problem and we look. So we're dealing with 50 black chairs and we're dealing with 60 white chairs. So we're going to have a bunch of black chairs and we're going to have a bunch of white chairs. All right, so we still need to find the GCF, but we have our scaffolding ready to start putting some numbers in. We'll find the GCF of 50 and 60. So let's scroll down and work on that. Find the GCF of 50 and 60. In fact, my circles here might be in the way. I'm going to have to move those down a bit just to get them out of the way. All right, so GCF of 50 and 60. Let's use prime factorization, and we'll make some factor trees. All right, so we'll put 50 over here, and the other number was 60. All right, and we'll start branching. In class, we talked about if you have a suspected GCF, I would like you to use that in both trees to start out. So you might think that the GCF might be 10. So let's put that in both trees, and then you'll proceed. So over here, what would be the other factor? It would be 10 times 5. And then the number 10 is composite. We need to keep branching. That would be 2 times 5. And then we would bring down the other number. Now, it might be clear why I'm putting that in blue font in just a moment. But let's go back. This tree is done. These are all prime numbers. There's no more branching to be done here. So let's go back up to the number 60. Now, we can just kind of copy what we have here for the 10. It's going to be the same thing. And again, I'm hoping that in a minute you'll realize why I'm choosing a separate color for that side of the tree. But over here, what's the other factor here? This would be a 6. And if I keep branching on that, that's going to be 2 times 3 to get the 6. All right, so that prime factorization is done. Now, when we're trying to find the GCF, then we can use a Venn diagram to help us with that. We would put the prime factorization for the number 50 in the circle. The prime factorization for 60 would go in this circle. And where we have factors in common would go where the numbers, or the circles rather, interlock. So what's a match? Now, the reason why I put this in blue is because you should see that that's a match. We have matching 2s, so we would write that down. We have matching 5s, so we would write that down. And that's all that's a match. Now remember, if I was interested in the LCM, I would put this 5 over here. This 5 right here would go here. And these numbers here, the 2 and the 3, would go over here. And I just want to remind you that the circle itself, if you've not missed anything, the entire circle, so let's just go back to the idea of 50. Everything that's in this circle here, the one that I'm hovering over, those numbers, if you were to multiply that together, should give you 50. And everything that's in this circle, including the red and the purple font over here, if you multiplied that together, it should give you 60. But when you're finding the GCF, you're only multiplying the numbers that they have in common, which are these red numbers, so that would end up being 10. So the GCF is 10. Now, if you're able to use the strategy of using the suspected GCF in your factor trees, sometimes you can recognize that it's going to be 10 even before you finish the tree when you realize that the other factors wouldn't share any common factors. So the GCF is 10. Let's write that down. So the first part of this question does say, what is the greatest number of chairs that he can fit in each row? It's going to be 10 chairs per row. That'll be the answer to part 1 of this question. But there's a part 2. The part 2 part says, how many rows of each color chair will there be? So we'll use the distributive property to figure that out. So we have to say to ourselves, 10 times what is going to give us this 50? 10 times what would give us 50? And that, of course, would be 5. And then you're going to say to yourself, 10 times what would give you 60? 10 times what would be 60? So I'll let you go ahead and figure that out. So you're going to put some number here. But it's going to be 10 times some number that's going to equal 60. All right, now, just something that I want you to get in the habit of checking. The chairs don't disappear. They're just rearranged differently, right? So if we add up our 50 black chairs with our 60 white chairs, and we ask ourselves how many chairs do we have altogether, we're going to get 110 chairs altogether. So if you go ahead and add these two numbers and get some number and multiply it by 10, 10 times whatever the sum is of these two numbers should equal 110. So just make sure that it does to validate the fact that you've done this correctly. Now, the other thing that I want you to be careful about, if you look at question 3, there's 3A and then there's 3B. So 3A is just asking you for the GCF, but 3B is asking you to identify, the number of chairs and what color. So be careful because you may look at this question. This has a 5 and a 6. This has a 6 and a 5. You want to pay attention to the color of the chairs. Be very careful. All right, good luck finishing that up.